Now turn to Section 4. You will hear a lecture about the history of timekeeping. First, you have some time to look at questions 31 to 40. Now, listen carefully and answer question 31 to 40.
Good morning, everyone. Today I'd like to talk about something we all take for granted: time. Specifically, how humans have measured it throughout history. This topic connects astronomy, physics, and social development. Let's start with ancient civilizations. The earliest timekeeping devices were actually quite simple. Around 3500 BC, the Egyptians created the first known sundial. This worked well during daylight, but obviously had limitations. At night or on cloudy days, people needed alternatives. The next major development came from the Babylonians. They divided the day into 24 hours, a system we still use today. Interestingly, they used a sexagesimal system, counting in 60s. That's why we have 60 minutes in an hour and 60 seconds in a minute. This base 60 system actually made calculations easier because 60 divides evenly by many numbers. Moving forward to medieval Europe, monks needed accurate timekeeping for their prayer schedules. They developed candle clocks and water clocks, but these were imprecise. The real revolution came in the 14th century with mechanical clocks. The first ones appeared in Italian monasteries, then spread across Europe. These early clocks had no minute hands, only hour hands. Can you imagine? Now, accuracy became crucial for navigation. Sailors needed to know their longitude at sea, which required precise timekeeping. In 1714, the British government offered £20,000 prize for anyone who could solve this problem. A carpenter named John Harrison spent 31 years building his famous H4 chronometer. His final design lost only 5 seconds during a 6-month voyage to Jamaica. This was revolutionary. The 20th century brought electronic timekeeping. Quartz clocks, invented in the 1920s, use crystal vibrations. They're accurate to about 15 seconds per month. But scientists wanted better. In 1955, the first atomic clock was built at the National Physical Laboratory in England. These measure time using cesium atoms and are accurate to 1 second every 1.4 million years. Today, global timekeeping is coordinated by the Bureau International in Paris. They maintain Coordinated Universal Time, or UTC. Modern atomic clocks are so precise that they actually detect tiny variations in Earth's rotation. Because Earth's spin is gradually slowing, we occasionally add leap seconds to keep our clocks synchronized with astronomical time. Looking ahead, researchers are developing optical clocks. These use light rather than microwaves to measure atomic vibrations. An optical clock built in 2015 at the National Institute of Standards and Technology wouldn't lose or gain a second in 15 billion years, longer than the age of the universe. Before I finish, let me mention social impacts. Standardized time zones were only introduced in the 1880s. Before that, every town kept its own local time based on the sun. The railway companies actually pushed for standardization because train schedules became impossible to coordinate otherwise. The International Meridian Conference in 1884 established Greenwich as the prime meridian. So next time you check your phone for the time, remember, you're connected to thousands of years of human ingenuity, from ancient sundials to atomic precision. Any questions?
This is the end of the test.